For today's lesson, our focus standard comes from Grade 8, Expressions and Equations, Topic A, Standard 1. Know and apply the properties of exponents to generate equivalent expressions. The topic for this lesson is exponents, rules for multiplying and dividing. Our essential question is, what patterns emerge when multiplying or dividing exponents with the same bases? So please take a moment, pausing the video if you need to copy down the header, sub your question column, and the note column, and resume the video when you're ready to begin. So one thing I really want to make sure that I point out is that all of our examples are going to involve values that have the same base number. And so in that scenario, we're looking for what patterns emerge that are going to help us simplify down a more complicated exponential form into one simplified exponential form. So let's go ahead and take a look. We're going to go ahead and jump right into it. So I've set up 3 different problems for us to take a look at today for multiplication of integer exponents. So here's our first problem. We have 6 squared times 6 cubed, or 6 to the second power times 6 to the third power. And so here's what I'm talking about. We have the same base number of 6, but it's pretty complicated. We have 2 different terms happening here. We want to see if we can get all the way down to one value in exponential form. So first, we're going to try expanding out each part of the problem and then simplify it. So 6 squared, or 6 to the second power, means 6 times 6. And we want to take that and multiply it by, so we multiply here, by 6 to the third power. Well, 6 to the third power is 6 multiplied by itself 3 times. So in expanding this out, what we see is it's 6 being multiplied by itself a whole bunch of times. So instead of writing it as 2 values in exponential form, how would we simplify that down to 1 value in exponential form? Since 6 is our number being repeatedly multiplied, 6 is going to stay our base number. What is our exponent going to be? To figure that out, you're going to have to count up how many total times is 6 being multiplied by itself. So if you came up with 6 to the 5th power, I would agree, because our 6, when we see it in expanded form, is being multiplied by itself 5 times. So 6 to the second power times 6 to the third power simplifies all the way down to 6 to the 5th power. So let's try our second problem. We have 5 to the 4th power times 5 to the 6th power. Go ahead and see if you can expand that out, and if you're feeling confident, to simplify it back down to one value in exponential form. Pause the video if you need to, and then check back to compare your work with mine. So 5 to the 4th power means we're going to take a base number of 5 and multiply it by itself 4 times. It'll look something like this. And then we're going to take 5 to the 4th and multiply it by 5 to the 6th. So I've added another multiplication sign here, and 5 to the 6th is going to be 5 multiplied by itself 6 times. Again, we see that our base number 5, when we expand all this out, is the same all the way through, and it's being repeatedly multiplied. In fact, it's being repeatedly multiplied 10 times. So it simplifies down to 5 to the 10th power. If you haven't done so already, please go ahead and try the third problem, pausing the video if you need to, and then resuming when you're ready to check your work. So we have 4 to the 7th power times 4 to the 5th. 4 to the 7th power is expanded out to be 4 multiplied by itself 7 times. And we take that, multiply it by 4 to the 5th power, which is 4 multiplied by itself 5 times. So when we expand it out, we see that we're multiplying 4 by itself 12 times. So that means we can take 4 to the 7th power times 4 to the 5th power and simplify it down to 4 to the 12th power. So with these 3 examples, I'm hoping that a pattern is starting to emerge. What are you noticing that if all you saw was 6 to the 2nd power times 6 to the 3rd power, how could you skip over this expansion step and know that it would be 6 to the 5th power? Same with our second and third problems. So what I'd like you to do is think about that for a moment and record your thoughts. Once you've recorded what you think the pattern is, go ahead and resume the video, and we're going to try and look at the pattern for division. Alright, so here we go. We have 3 more problems for looking at the division of integer exponents. So 7 to the 8th power over 7 to the 5th power. May look like just a fraction, but this is a good time to remember that fractions are a form of division. So just like with the multiplication examples, we first want to expand it out and then see what we can do to simplify it down to one number in exponential form. So 7 to the 8th power is going to expand out to be 7 multiplied by itself 8 times. And 7 to the 5th power is going to expand out to be 7 multiplied by itself 5 times. So from here, we want to look and see, what can I do to simplify this? One thing we can do is look for things that cancel out from the numerator and the denominator. Let me show you what I mean. Here, I've gone ahead and crossed out 1 7 from the numerator with 1 7 in the denominator, because 7 divided by 7 is just 1. So how many more times can we do that? Well, we have a 7 and a 7 here, so let's cancel those out. And it looks like we can do it a few more times. In fact, we can cancel out 5 pairs of 7s, canceling out each time 1 7 from the numerator with 1 7 in the denominator until we run out of pairs of 7s that we can do this with. And once we've done canceling, and again it has to be the same value, once we get done doing that, all we're left with are these 3 7s. 7 times 7 times 7. So we can simplify to write all that we have left once we've done the cancellation to being 7 to the 3rd power. Go ahead and try that with our example here. 3 to the 8th power over 3 to the 4th power. What would it look like when you expand it out? What can you cancel? How is it going to simplify? Go ahead and pause the video and try it on your own. Then resume the video when you're ready to check your work with mine. So when we expand this problem out, 3 to the 8th power is 3 multiplied by itself 8 times, and 3 to the 4th power is 3 multiplied by itself 4 times. Now we start to look for what pairs of numbers in the numerator and denominator can we cancel out. And it looks like we should be able to cancel out 4 pairs. So once we get done canceling the pairs of the same values, 3 divided by 3 is 1, 3 divided by 3 is 1, so on and so forth 4 times, all we're left with is 3 times 3 times 3 times 3. Well, that can be simplified to being 3 to the 4th power. So 3 to the 8th power divided by 3 to the 4th power becomes 3 to the 4th power. Go ahead and try our final example. 2 to the 10th power divided by 2 to the 7th power. Two to the 10th power is going to expand to be 2 times itself 10 times. And 2 to the 7th power is going to expand out to be 2 times itself 7 times. And once we expand it out, we can start to say, well, this 2 divided by 2 is 1, so that would cancel. And see how many times can we cancel. If you found that 7 pairs of 2's cancel out, and again it's always 1 from the numerator with 1 from the denominator, because when we divide a number by itself it becomes 1. We can do that with 7 different 2's. All the 7 2's in the denominator cancel out with 7 of the 2's in the numerator. That leaves us with 2 times 2 times 2. Because it's repeated multiplication of the same number, we can say that 2 times 2 times 2 is 2 to the 3rd power. So 2 to the 10th divided by 2 to the 7th power, through all this work we can see simplifies to being 2 to the 3rd power. So like we did with our problems in multiplication, I want you to look and see what patterns are emerging. What can we do to get from this, the original problem, to our simplified problem? What rule might we use? Go ahead and record your thoughts below. And once you get that written down, that's going to conclude our video lesson for today. So take a moment to make sure that your notes are fully complete, that your header is written down, and that you have all of the notes copied into your math journal, and you've included a summary at the end of your notes. And then we're going to discuss this as a class and see if we can come up with the rule to use for problems like this so we don't have to expand every single one.